This is question number 4 from the exercise 13.4 from the chapter probability. The question is, in this question we have to find the probability distribution in these three parts which are given to us. Okay, in the first part we have to find the number of heads in two tosses of a coin. Okay, so let us begin this question. So to solve this question, because we have to find the probability distribution of number of heads in two tosses of a coin. Okay, so first thing we consider is the sample space of two tosses of a coin. Okay, so when a coin is tossed two times, so we can get both heads, head tail, tail head or tail tail. So these are the outcomes which are possible. Okay, so this is a very simple experiment of tossing a coin two times. Okay, so we are not discussing it further, and in this case, because we have to find the probability distribution of number of heads in two tosses of a coin, so we assume that x is the number of heads obtained. Okay, so x can take 0, 1 or 2 as its value. So the random variable x can have the value 0, 1 or 2 because we can get, when a coin is tossed two times, none of the outcomes as head. Okay, one outcome as head and both the outcomes as head. Okay, so probability of x is equal to 0. That is probability when we obtain no head is the probability that we obtained both the outcomes as tail. This would be equal to 1 by 4 because there are 4 outcomes and only favorable outcome is 1 when we consider that both the outcomes are tail, and this would be equal to 1 by 4 because only one outcome is favorable. So favorable number of outcomes upon total outcome would give me 1 by 4. And here it should be noted that probability of getting head or probability of getting head tail or probability of getting tail head or probability of getting tail tail, all of them would be equal, and this would be equal to 1 by 4 because there are total outcome and only one outcome is favorable when we consider any particular probability of event. Okay, and probability when x is equal to 1, that is only one head is obtained, so this would be equal to the probability of getting head tail plus probability of getting tail head, and this would be equal to 1 by 4 plus 1 by 4, so this will be equal to 1 by 2. And probability when x is equal to 2 would be equal to the probability of getting both heads, and this would be equal to 1 by 4. Okay, so we can write the probability distribution of number of heads by making a table of the number of heads, that is the value of the random variable, that is x, and probability of x. And when x is equal to 0, so probability of x is 1 by 4. When x is equal to 1, probability of x is 1 by 2. And when x is equal to 2, probability of x is 1 by 4. Okay, so this is the required answer, that is the probability distribution of number of heads. Now moving to the second part of the same question. In this question we have to find the number of tails in the simultaneous toss of 3 coins. So to solve this question, first of all, we are going to consider the sample space of the simultaneous tosses of 3 coins. Okay, so we have taken 3 coins and we are tossing them. So the sample space that could be obtained would be like this. All the 3 outcomes as head, that is the first coin shows head, second coin shows me head, and third coin shows me head. Similarly, in the second outcome is like this, that first 2 coins are showing me head and the third coin is showing me tail, and so on. So this would be the sample space. So this we have solved in the previous exercise, so no need to explain it further. Now further we assume that let x be the number of tails obtained. Okay, because we have to find the probability distribution of number of tails in simultaneous tosses of 3 coins, so we assume that x is the number of tails obtained, and x can take the values as equal to 0, 1, 2 or 3 because the number of tails in each outcome can be 0 when none of the times tail is obtained. We can obtain only one tail in 3 outcomes. We can obtain 2 tails in 3 outcomes. We can obtain all the 3 tails in 3 outcomes. Okay, so it is very clear. So probability when x is equal to 0, that is probability when none of the time tail is obtained, would be equal to probability that all the 3 times head are obtained, and this would be equal to 1 by 8. And it is quite obvious because only one favorable outcome upon total number of outcomes. And here it should be noted that the probability of each outcome would be equal to 1 by 8. That is, probability of head tail would be equal to 1 by 8. Probability of head tail head would be also equal to 1 by 8, because here we have only one outcome and which is favorable to us, and total number of outcomes are 8. Okay. So similarly, probability when x is equal to 1, that is only one tail is obtained, would be equal to probability of head tail plus probability of head tail head plus probability of tail head head. So you can see that we have considered those events in which only tail is obtained once, and therefore the probability when x is equal to 1 would be equal to 1 by 8 plus 1 by 8 plus 1 by 8, and this will be equal to 3 by 8. Now similarly, probability when x is equal to 2, that is 2 tails are obtained, would be equal to probability of head tail plus probability of tail plus probability of tail head, and this would be again equal to 3 by 8. Okay, and probability when x is equal to 3, that is all the 3 times tail are obtained, would be equal to 1 by 8. Okay, so we can now write that the probability distribution of number of tails in simultaneous tosses of 3 coins as equal to, this is the value of the random variable x and probability of x. So when x is equal to 0, 1 by 8, when x is equal to 1, 3 by 8, when x is equal to 2, 3 by 8, and when x is equal to 3 is equal to 1 by 8. So this is the required probability distribution. Now we shall move to the third part of the same question. In the third part, we have to find the probability distribution of the number of heads in 4 tosses of a coin. Okay, so to solve this question, first of all, we consider the sample space of 4 tosses of a coin, and this would be equal to these outcomes. Okay, so we can easily prepare the table of the sample space of 4 tosses of a coin. We have done this question previously also in previous exercises. So we are not explaining how the sample space of 4 tosses of a coin is obtained, because it is quite simple at this level. And here we have to find the probability distribution of number of heads in 4 tosses of a coin. Therefore, we assume this random variable x, which is equal to number of head obtained in 4 tosses of a coin. And it should be quite clear that x can take the value 0, 1, 2, 3 or 4, because when x is equal to 0, we are going to consider those conditions in which no head is obtained. When x is equal to 1, we are going to consider those cases in which only head is obtained once. Okay, so x is equal to 0, 1, 2, 3, 4. What does this mean? They mean that that how many times head is obtained when a coin is tossed 4 times. So therefore it can take the minimum value 0 and maximum value as 4. Okay, and it should be noted further here that the probability of particular outcome, that is, if we are going to talk about the probability that all the 4 times head are obtained, or the probability that the first 3 times head are obtained and then the 4th time tail is obtained, it is a particular outcome of the sample space, or it is a sample point. So probability of sample point in this case would be equal to 1 by 16, because there are 16 outcomes and only one particular outcome would be there whose probability is being calculated. So probability of any particular outcome would be equal to 1 by 16. Okay, now probability when x is equal to 0 means that in all the 4 outcomes we are not going to obtain head. So this would be equal to probability that head is obtained in all the 4 outcomes, tail is obtained in all the 4 outcomes, and this would be equal to 1 by 16. Okay, probability when x is equal to 1 would be those outcomes in which head is going to be obtained only once, and it is going to be represented by these outcomes whose probabilities are written, and this would be equal to 1 by 16 plus 1 by 16 4 times, and this would be equal to 4 by 16 or 1 by 4. Similarly, when probability of x is equal to 2, that is head is going to be obtained 2 times, would be equal to these outcomes plus these outcomes. So you can see that in all these outcomes, the head is going to be obtained only 2 times, and these are 6 outcomes. So 1 by 16 would be added 6 times, and this would be equal to 3 by 8. 6 by 16 or 3 by 8. Moving further, probability of x is equal to 3, that is head is going to be obtained 3 times, would be equal to these outcomes. Okay, and this would be equal to 1 by 16 plus 1 by 16 plus 1 by 16 4 times, and this would be equal to 4 by 16 or 1 by 4. And probability of x is equal to 4, that is head is obtained 4 times, would be only this outcome, probability that head is obtained 4 times, and this would be equal to 1 by 16. So we have calculated the probability of x is equal to 0, x is equal to 1, up to x is equal to 4. Now we can write the probability distribution of number of heads in 4 tosses of a coin as, first of all, we write the values of the random variable 0, 1, 2, 3, 4 and probability of x, and on completing the table, this would be the probability distribution of number of heads in 4 tosses of a coin. So this is how we are going to solve this question. Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.